Okay, well, I will go ahead and kick it off. So my name's Megan Roddie-Fonseca. I am a security engineer at Datadog, and I also co-author and teach Forensic 509. I am looking forward to this workshop today. So we hopped in for the last one of the year, so hopefully we end on a strong note for those of you who have been coming to the workshops. Terrence, did you want to introduce yourself quick?
Yes, I am Terrence Williams. I am a certified instructor for SANS, teaching the 4509 course that Megan mentioned that she's a co-author on. By day, I am a security engineer at AWS. So excited to start. I'm going to go ahead and turn my camera off and let Megan start the show.
Perfect. Okay, so today what we're going to do, let me go back. Uh, our plans for today, we're going to start. I'm going to give you guys kind of a Google Cloud fundamentals intro. I know that Google Cloud is probably the less frequently observed. Throughout the year, you guys have been doing AWS and Azure focus workshops more so, I feel like. Sorry about the glitching of the slides. So I'm going to go through a few concepts, definitely not comprehensive, only a little bit of time, but hopefully enough that when you start looking at the logs, you kind of have a better understanding if you're not super familiar with Google Cloud on what you're looking at. After that, Terrence is going to give a primer on investigations in Google Cloud. So what you're looking for in the logs, how we trace activity through logs and lateral movement, things like that. And then the part that probably most people are waiting for to get hands-on, we do have a lab. We're going to be leveraging SOF-ELK. So while your lab environments are spinning up, you do need an AWS account to deploy the VM. We are going to quickly show you SOF-ELK and then let you get hands-on. And after that lab's over, we'll go ahead and review it quick before we let you get on with your day. There is the Discord where you can post questions while I'm presenting. Terrence will try and answer questions and vice versa. There's the Zoom Q&A where you can also ask questions. And then just a heads up, at the end of this, we do have a quick 4-question survey for everyone to fill out. If you've ever taken a SANS class, you know that we highly value our evaluations. We take all the feedback to heart. And if you want to keep doing these workshops, you know, we provide these for free. We have to have the justification knowing that people are actively participating and enjoying it. So that survey tells us that you want us to keep doing this content. So don't neglect doing that. It's really quick. It's anonymous. Highly recommend it. With that, we are going to jump right in. So the fundamentals. First, I'm going to start with IAM. IAM is kind of the cornerstone of everything in the cloud. You, as a threat actor, have to get access. In order to get access, you need to interact with the environment some way. You need to, you're going to see that in IAM via the access. And whether you're a service account or an actual user account that's compromised, you're going to touch IAM in some way. So understanding the Google Cloud structure is very similar to a lot of what we see in AWS and Azure, where you have like projects and subscription groups and management groups and accounts. We have our own structure here in Google Cloud. So we have a Google Cloud organization, let's say Aviata, our company that you've been observing throughout these workshops. Aviata can have folders. It can also have subfolders in those folders. So it's a very directory-like structure. For simplicity, let's say we have a couple of folders that divide up our production and experimental environments. Now, it could be production and dev. You could use folders to divide by the departments if you have like HR and finance and IT. So it's really just a way to organize it logically so everyone knows where their stuff is. So let's say it's production and experimental. Within the production, maybe we have some projects. So the projects are the bundling of resources. So these resources, they should logically go together with each other. So that may be the core infrastructure, our compute VMs and the storage buckets that interact with those. Maybe we have another project that's specifically for security logging. And in that project, we have pub sub resources and storage buckets to store those logs. So you have those logical groupings of different resources within those projects. And then maybe on the experimental side, we have a research and development project. People just stage various data, whether that's VMs or network resources or storage bucket. Any types of resources will go within a project. And then again, folders are just logical groupings. At all these levels, you can apply permissions. So if you give someone permissions at the Aviata level, the permissions they have, let's say editor, they'll have editor on all those folders, projects, and resources nested underneath. You could give permissions at the folder level, project level, or on the individual resources. So you have a lot of options for how you control access, depending on how broad the access is needed. But you always want to follow least privilege. So how do we assign those permissions? In Google Cloud, what happens is you create a policy, and a policy is made up of a principal and a role. A principal is essentially a user or an account, and that can be represented by a lot of things. It's not just you as a user, me, Megan at Aviata Cloud. That could be me, or it could be a service account. If you're connected to Google Workspace, it could be a Google Workspace group or user, or it could be all Google users, anyone who has a Google account. So different definitions, different ways to assign those, to choose who gets permissions. That principal is then bound with a role. So that could be something very high level. We don't typically recommend these because it gives a lot of permissions, most of which probably aren't needed and are going to be abused by attackers if they do get into your environment. But those are the basic roles: owner, editor, viewer. You can have predefined roles. So maybe it's something like a storage bucket admin who can read, write, delete, create anything in the storage buckets. Okay? And then custom roles, which are just those individual permissions you can build custom roles out of. So you take a principal, you take a role, and that creates a policy that is assigned to either resources as in objects and services or folders and projects. This is a bit different, I feel like, than how IAM's handled in a lot of environment. That binding together is applied to the resource. So really the resource is receiving permissions. I am not just given editor permissions. The resource is validating that I am an editor of that resource. So role specifies the group of permissions and scope. That could be just a couple permissions like edit a bucket, delete a bucket, or it could be a broader set. The members in this JSON binding, that could be users, groups, service accounts, and then the binding is applied to the resource. So this policy alone, sorry, it's allergy season down here and everything else season, so I apologize for my congestion. This JSON policy here, it does not inherently give me anything. When I create this policy, I do not have editor role anywhere. What happens is I'm going to go to, let's say, a VM. I have a compute VM in the cloud, and I apply this policy to that VM. If that happens, then I and the security group have editor permissions solely for that VM. If I applied it to the project that the VM was in, I'd have editor permissions on the project, on the VM, and all the other resources within the project and the project itself, if there's something like project management permissions. Okay? So hopefully this makes sense and we're understanding how permissions are granted. Again, feel free to ask questions in the chat and Q&A. If you're lost here, we'll try to provide a little bit more background. So let's talk about service accounts. So the reason I'm going to focus in here is if you look at things like the Google Cloud threat landscape report, or really any threat landscape reports that are being released about the cloud from any vendors, you'll see that one of the biggest vector compromise for Google Cloud is default service accounts. Okay, so there's different service accounts. You can create one. So it's a user managed one. You create it, set the permissions, all of that. There's the default accounts, which we're going to focus on. And then there's service agents. Those are more Google managed to require like cross-resource or cross-service communication. But I want to focus for a second on the default service accounts. When you create a VM or a Kubernetes cluster or container, it will ask you to associate a service account. If you change no settings, it is going to create a default service account and give it default access, which is a subset of different API permissions, but it's a pretty broad subset. So you can use your own account that has the permissions restricted. You can do this. So the access that's going to be given is going to be default. So the permissions commonly needed by a service account on a VM, but it's going to give editor, the account's going to get editor permissions on the project. It's scoped down by that allow default access, but regardless, just having this default account with broad permissions on your project is not great. The good news is if you created your Google Cloud organization since May of this year, they've disabled this being the default behavior. Now you cannot create default service accounts when you create VMs. That's not the default behavior, but only if your org was created since then. Any orgs created before, this is still the default behavior. And as we know, engineers, through no fault of their own, they've got a job to do. They tend to take the easy route a lot of times. When they spin up a VM, they don't want to figure out all these custom service accounts and things when they're given the option to just hit go and it gives them the account they need and they can do it. Okay. Now, service accounts, you're going to see two types of credentials. There's short-lived credentials, so like a temporary access token, but what's commonly used is the service account key. So another thing you'll see with threat actors is they'll create API keys on service accounts or on user accounts, but especially if these service accounts are created and they're created with the permission to create keys, they can create these non-expiring service account keys. Okay. Then just a couple other details about service accounts. An interesting thing about service accounts is they are a resource and they are a principal. So what that means is for a VM, I can create a policy that says this service account has access for this VM. So that would be the service account acting as a principal is granted access to the resource. But I can also grant access to the service account because it's a resource. That means me, Megan, there can be a policy applied that says Megan is allowed to create service account keys for this service account. So again, that's super relevant because maybe the service account wasn't compromised, but I was compromised and I'm allowed to create service account keys for that service account. And maybe that service account has more permissions. So I can't delete a VM, but that service account can, and I can create keys for that service account. So by proxy, I can delete VMs. Okay? So here's kind of that nuance with service accounts, and another thing that presents a lot of risk with service accounts. Besides the fact in general that service accounts not being tied to a user, sometimes there's oversight that's lost. They get created with all these VMs to do things that need to be done, but they're not well managed. So just something to keep in mind. We'll see in our scenario later the abuse of that. I want to mention Cloud Asset Inventory quick. This is an interesting tool because for threat actors, it can provide a lot of insight into the environment. So it's described by Google as a global metadata inventory service that allows you to view, switch, export, monitor, and analyze your cloud asset metadata. In terms of what data it covers all the different resources, all of those assets. It'll let you look at the policies. Then if you have OS inventory management, so if you're looking at the operating system layer on that VM, it can give you runtime information about those operating systems. So you can list assets, you can understand the relationships, so you can say what project or org is this resource part of. You can search for resources, so if you're looking for something specific, and then for those resources, look at the IAM allow policies. So understanding who can access that resource. And then analyzing IAM and org policies as a whole. So what restrictions are there at more of the org level versus the resource level? Now, the reason I mention this is a huge vector of abuse for threat actors. When it comes to resources, they can identify targets of value for lateral movement and data theft. So even if they have a read-only permission for cloud asset inventory, I'm saying this exposes a lot of reconnaissance information for them. So they can say, okay, well, here I am, but when I look at cloud asset inventory within this project, there's also these storage buckets. And they're locked down and they have this name that indicates maybe there's some value there. They can understand the org structure for lateral movement. So again, okay, I'm in this specific resource. I compromise this VM. I have access to the service account. What other resources are in this project? But what about when I go above the project? What folder am I in? How do all this structure relate? Almost like it reminds me of mapping a network in traditional on-prem environments and visualizing that network infrastructure. This is essentially the same thing. They can visualize that infrastructure and understand what they may have access to or what they can gain access to if they can expand their permissions. And then the IAM analysis side of cloud asset inventory, seeing the policies, that really helps in determining the scope of the compromised account. So somebody compromises my account, Megan, they want to understand, what can I do? What permissions do I have? Do I have, like I said, permissions to create keys on service accounts? Okay? So really powerful reconnaissance tool for users in the environment to kind of understand that. Last topic I want to get into is the logging. Today, we say in the DFIR course 4509, a lot of students come in and expect a lot more hands-on cloud interaction. It's fair, it's a cloud course, but in reality, cloud investigations is just log analysis. If you have a SIM in your organization, you're likely not even going to be that active in the console. Maybe to dive into some extra information. Once you scope out the compromise, try and like look at the resources directly. But in general, your actual investigation is going to be in logs. And unless you're using cloud native logging, it's going to be in a SIM. That's why we use SOF-ELK in our 4509 course. That's why we're going to use SOF-ELK today. A lot of times all you're doing is looking at the logs. I will see today in the lab, there's some restrictions on that based on how the logs are being parsed and filtered. But sometimes that's what you have to work with. And you learn lessons about logging gaps and you tune your SIM for that. But we're going to focus on logging just so you understand how things are logged and what you'll see in the logs. Now, when it comes to audit logging in Google Cloud, we have some key log types we're going to focus on. The first one's admin activity logs. Probably along with login audit logs, I'd say this is one of the most important logs. They're enabled by default. It cannot be disabled. And it records API calls and actions. So another thing with the cloud, everything's an API call. The cloud console is just a wrapper for all those API calls. And so audit logs are just logging API calls, even if you clicked a button, but on the back end, it's an API call. So any calls or actions that modify resource configurations or metadata, that is what's going to be in admin activity logs. So write events. Not read events, not somebody looked at the policies, but that somebody created a policy or changed a policy. For resources, it's going to be that a storage bucket was created. Not that a file was created in that storage bucket. We're talking resource configurations and metadata, not within the resource. We'll get to that in a second. Another one is system event logs. So potentially relevant, enabled by default again, cannot be disabled. A little less relevant, I feel like, personally, in the scope of an investigation, just because this is system-driven changes, very infrastructure-based, not based on user interaction. So if you're looking at a threat actor interacting with the environment, you're more likely to find that in the admin activity logs. The login audit logs, this is the other one I said that was one of the key ones. Again, enabled by default. This is important because it's going to give you user authentication events. That could be console logins, API authentication, or CLI via the G Cloud tool. Okay? So any of those authentications, that's where we see them. I mentioned when I started with the conversation on IAM, that IAM is the cornerstone of everything. Those logs are highly relevant. Policy denied audit logs, also enabled by default, cannot disable. But in this case, you can add exclusions if there's stuff that you don't want logged there, maybe because of just logging bandwidth. These logs specifically log when stuff is denied. So if a user tries to take an action and the IAM policy denies it, you will get an event in this log that says that they failed to do that. Right? Now, data access logs are super valuable, but the key thing here is they are disabled by default. You have to enable these. And there are two different sets of data access we can talk about. There is the read of resource configurations or metadata. So that resource configure metadata, it's the same I referred to in admin activity logs, but it's the read events. So somebody listed the buckets in our environment. Somebody looked at the IAM policies or the list of users. They're looking at an admin level, the resource administration, the resource configuration level, but it's a read event. So if you enable those will go to access logs. The second half of this is what we call the data plane. So it's the create, read, or modify. So we're getting into write events, but on resource data. So that's where we talk about items being added to a bucket. That's not an admin event, even an admin read event. It's a data write event because you're interacting within the resource. Or on a VM, that could be operating system logs if you enable those and forward those. The last one, not super worth mentioning, but just in case you see it and you wonder what it is, there is the access transparency log. As a Google customer, they do have in their contracts some capabilities and access to your environment, whether that be for troubleshooting or data analytics or whatever. If Google personnel take actions on your environment, there is a log of that in the access transparency logs. So this is kind of just a breakdown of those two logs I talked about. We call it the control or the management plane and the data plane. So it's two levels. It's the management of the cloud, and then it's the data in the cloud, in those resources. So the admin activity logs are at the control plane. They give you write events as the resource management level. And if you choose to enable it, you can also get read events for the control plane. So that's creation of a VM, deletion of a VM, or on the right side, that could be creation of files within a storage bucket. In the data access logs, those are read and write events, but at the resource level and are non-default. Examples are application logs you forward from a VM, files in a storage access being read, flow logs on a subnet being logged, so those network flow logs. So again, within the resource versus management of the resource is what I'm trying to get at here. So hopefully with that, you kind of, if you haven't seen GCP before, you feel a little more understanding about the organizational structure, how things are managed and how things are logged. If you don't, feel free to ask questions in the Q&A or in the Slack. And with that, I'm going to hand it off on Terrence to get onto like kind of our investigation side of things.
All righty. Thank you, Megan, for that primer. The reason we had to do that primer is because Google Cloud operates just slightly different than what we're used to in our traditional RBAC model. So that role-based access control. So all those details Megan has went through about how does IAM work? What are policies? What do we expect our logging to be? This is going to be fundamental to understanding the investigations you're going to do in Google Cloud. We're going to focus on one particular style of investigation building up here. So let's start with investigating our authentication activity, and then you'll see that we're going to progress this to looking at lateral movement, and which will then lead us to our hand-on exercise here. So going back to what Megan was talking about with the IAM models, we talked about the different principles that can be a member inside of a policy binding. So those members have their various ways that they're able to authenticate to Google Cloud. So Adam saying these things, think about this as like a little cheat sheet, because this cheat sheet is going to build on top of each other for us to then consolidate into when it's time to do our investigation. Oh, when I see this, I know what it means. So when you're looking at things like the primary authentication methods, you'll see your user accounts, you're going to see the OAuth, and you'll see API keys. Hopefully not as many API keys, because you'll notice that Google Cloud, compared to the counterparts of AWS and Azure, are very good at making sure that OAuth authentication is baked into all the different levels that you can access Google Cloud, meaning the console, the CLI, or the API. So a user account, when you're going in, let's say for the CLI, you're able to say gcloud auth login. That's using that gcloud CLI. I'm saying that I want to authenticate and log in. That will open up my OAuth 2, allow me to authenticate, say who I am, and then I'm off and running as Terrence Williams. The other types of authentication that you'll commonly see will be some service account authentications. This gets a little more tricky because the service account authentications aren't necessarily telling us that when I'm doing this login, I'm logging in as a service account. Go back to those IAM policies and the bindings. So Terrence at Aviata Cloud is allowed to assume the role of the service account, and I'm allowed to use the permissions of the service account to use its bindings compared to just Terrence's bindings. There's going to be various different ways that that service account can authenticate. And it does depend on what type of activities you're doing. Something as simple, you can do the key pairs. These are going to be a little more dangerous in our world because that's what people commit to their code bases that allow them to be on like a GitHub. Luckily, GitHub, Google Cloud, AWS, and Azure, they're starting to monitor those type of updates. But it does say, let's move away from it. You'll have some other stronger identifiers like the workload identity federation and service account impersonation. These are going to be tricky for us in our logs to be able to attribute, yes, the service account made this action, but who instructed the service account? And when I say who, that could be a member here. So when we're going through and looking at these logs, we have an example of two logs here. The first one is looking at that user authentication log. So you can see here, this is just a snippet. So I carved this out of the larger packet that we're going to be seeing in the Google logging to show you that there will be the authentication information in there. So you can see here for the call that happened at the top, the authentication info is going to show you that principal email. So you'll see that Chappie at maligatorlabs.com was there. And what was their subject? Well, Chappie was acting as a user. What else do we know about this? Well, we know how they authenticated, and we have some metadata about their authentication, like their caller IP address and their user agent string. This is going to be very important because it also tells me which ways were they authenticating with the cloud. So right now we have our Mozilla. Oh, I always mess it up. See, I'm coming from a Macintosh, Intel Mac, and it's saying, hey, this is what they had as a user agent string. This can also be a Docker. This can also be the SDK. This can also be the CLI. You will be able to understand from this authentication log who, what, when, and where. For that service account, you see that it gets a little different. Well, the first part about service accounts that make this tricky is things like the default service account have the project ID. When you're working inside of Google Cloud, the project ID is usually, it has a project number. You usually will see the project ID. So the project ID will be something like Aviata Prod Cloud. That will be the ID. It's usually in human readable form. But like organizations and folders, they also have a number. And that number is usually not what you're seeing as much, but you will notice that the service account has the project number. This is particularly important when you're investigating these laws because I can tell where this service account is supposed to live. Going back to what Megan was talking about with our IAM and where the bindings are. Since service accounts live inside of projects instead of being created at the folder or the organization level, I can see that if there is a service account that has permissions on a folder or organization or another project, where did it originally live? What is it? And this is usually telling me some more signs that we're going to dive in a little deeper. We can see here that what method was called and the service name related to the method. All that was also in the user authentication one as well. It's just a different snippet on what you're going to see comparing. So the comparing and contrasting here is very important. So when we're having our investigation methods, let's tie this all together. How did they authenticate? Was it console? Did they use the console, then use the terminal inside, the cloud shell? Did they access through the API using SDKs, the CLI? What did they do? How did they do it? What level of permissions did they do it? When you are enabling audit logs in Google Cloud, that's going to be what saying is going to those places Megan mentioned about the logging. You have the 4 categories. Admin right on by default. So anytime admin right is happening, it is being logged across the board. Data right, admin read, and data read, those necessarily are not on by default. And this depends on your environment. So that example you see on the right for the data read, this may not be present in your environment if you did not enable it for the artifact registry for data read. If that is not enabled, you wouldn't see this log. But for the admin right, you will see here that permission type, because it was admin right, automatically log. This makes it challenging for us as investigators in our environment when we do not know what logs are on. Because as you can see in these examples, each of the method calls are broken down into their different permission types. And based off of what you have logged, those permission types are going to be very instrumental for understanding what were you able to see in your investigation. Was it logged? If it was not turned on, you're not getting that log. Now, how does this play into lateral movement? Well, with lateral movement, there are a few attack patterns that just stand out above the rest. Of course, in the cloud, Linux is still Linux, Windows is still Windows. If you expose the different ports open, if you misconfigure your systems, those are able to still do the same lateral movement that we're used to, laid out by MITRE ATT&CK. You can see all those. We're focusing now on what Google Cloud could enable someone to do. Megan mentioned that default compute service account. When it's first created with that editor role, it has a lot of permissions that you are hoping it does not have. One of them is the act as permission, where it allows it to act as different members that it has access to. It also has the ability to create API keys. So let's say you spun up your GCE, so your Google Cloud Engine, it has the default service count on there. And within the GCE, you'll have the metadata service that allows the GCE to understand what permissions it can handle. So IMDS, the internal metadata service, is across the board for all cloud providers. This allows the benefit of the cloud to be that autonomous nature. Something like that allows someone to exploit that machine, get access to the credentials for the default compute service account, and now they can laterally move around based off the bindings for that service account. Service account impersonation is building on top of that. Someone has the permissions to impersonate it. Then you also have things that we don't really think about all the time. If I did not compromise your instance, but let's say I compromise a role or a service account, instead of me trying to exploit every VM in your environment, I can create a snapshot. If I create a snapshot, something that is completely out of band, it's working in my favor and gives me a full clone of that running instance. So now I'm able to go grab all these snapshots, spin up my own project that I control, and I can have my own GCE instance. And now I just add those snapshots on, and I'm reading that data, getting the credentials from there or what you ever stored on it, what configuration you have, and I get to move around. A lot of what I just described for those attack patterns are aligned to just misconfigurations that we're doing in our environment. Instant response by the name says we should always be responsive. That is no longer true. We need to be proactive, especially in cloud environments, by understanding what's allowed in your environment. You want to understand what are the bindings. So going back to that Google Cloud inventory, that asset inventory is saying, let me go find all these editor roles in my environment. Let me find where people are exposing additional APIs and they need to. All that work ahead of time is going to allow you to bring the scope back for your misconfiguration. Someone gets access to this service account. What do they have access to? How can they do it? And where can they do that? This is going to be essential for us to understand how is our environment configured, because this can open a lot of doors. When you come down to your instance configuration, a lot of us are used to the Azure and AWS ways of doing a security group, where it is a firewall that's dedicated to a instance. In Google Cloud, you have a firewall that is global. So it's not going to be dedicated to one instance. So what that means is if you have that firewall that's globally configured to allow SSH from anywhere in the world, that means everything can get to SSH, meaning all these instances are now exposed. That firewall rule is not good. Making sure your firewall rules are tuned, how did it happen, is going to be great. Two of the attacks that we're breaking down into their different phases so you can see how this plays out. So the first one, we have the default service account. What you see here, you have that initial compromise of the compute instance. Someone got on there. Let's say it was a web application that was misconfigured. They were able to get access to the IMDS where they get their temporary credentials. And then they find out, wow, I hit the jackpot. This is what I needed. I have the editor role. And then what they find is on top of having an editor role, the scope is all cloud API access is enabled, meaning that this service account with the editor role can do all these actions across all these APIs. And then from there, it's just child's play. You're just having fun rolling around. This is actually an example of an open source project, Gsploit, GCPL or PLOIT, open source project where you can drop it into your environment and it will map out what editor roles are there and then move around. So you get to see this. When they did the threat horizon report, or what is it now for M trends, it also showed, I want to say, quoting off the top of my head, it was like 80% of IM exploits are still related to the editor role, which is why that change back in May was so important to make sure you're not getting that default service account being there. Then you have that snapshot-based access. So you're already in the environment. You're in there via some user or member that you compromise. You got API keys. Someone left their password and their password too simple. We're able to get there. They're going to go create the snapshots where they're at, restore those snapshots in their control environment, mount that disk, and from there, I'm doing my forensic analysis like we will be doing. We will just go through, oh, this one that I mounted, oh, you have this web server. Wow, you put a password in there. Great. I'm going to use this later. Boom. Keep going through and iterating through it. And you'll be so surprised how many people and organizations are saying, well, because no one can access my disk, I don't have to encrypt it at rest. Don't worry about that. It's just a disk. No, you still should encrypt it, because if I get the snapshot, I'm still going to have a great day. So when we're investigating this, we have our flow. Our flow here is aligning to the DARE model. So very much similar to the PERCL model that we saw, but a little more forward-leaning for our technicians. So we have our detection phase, analysis phase, incident response phase, recovery phase, and the documentation phase. I'm going to be very honest with you. I am awful at the documentation phase because you're always moving fast. You're boom, 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 boom. No, I don't have time to write it up. I don't have an excuse anymore. GenAI is, here's my investigation notes. Hey, GenAI, go make the documentation for me on reporting all this. I just got to make sure it's accurate now. Well, chef's kiss. But so what we're talking about here is when we're in that lateral moment, we need to detect it. We can detect lateral movement by going back and looking at those authentication logs, looking at what are the common attacks and misconfigurations. Did we find it? Do we have alarms? Looking through Google Cloud logging. Google Cloud logging is way more robust than what you're going to find in Azure and AWS, where this entire service allows you to build on top of it. If you want to use the default Log Explorer, go ahead. You don't like that? Use Log Analytics where you can write your SQL. You built the perfect SQL, make it into a cloud function that will trigger automatically. Your detection is quite easy once you know what you're looking for. Then analyze it. What happened? When did it happen? Is this normal? Do you have a baseline? Do you understand it? Is this service account new? Is this service account having roles it's not supposed to? The tricky part about analysis phase is it's not always linear. So I'm not always able to say on day one, I know this, day two, I knew this, day three, I knew this. Sometimes I find out at the end of the investigation that I detected you, and there was a lot of information I didn't know yet. So that analysis phase needs to be understanding of a holistic approach. Then you have your instant response phase broken into two things, your immediate actions and your mitigation controls. We are great at immediate actions. Me and Megan did a survey last year for the instant response, and it was like, yes, we're getting rid of them. We get people out of there, and then people follow up with well, we did get exploited again by the same TTPs. Right, because you have to roll out those mitigation controls. Luckily, Google Cloud does have some built-in mitigation controls, like not enabling all APIs when you are inside of a project, meaning that because I did not explicitly enable the API that allows you to create API keys, you can't do it. So that is a mitigation control. There's also things that you can do by OS login. This is trying to get rid of all those key pairs that everyone leaves on their desktops. I know, right? Who would do that? But you go ahead and disable things that are not supposed to be used, auditing your IAM policy. Do you really need this? And then once you recover, recovery only happens after you analyze your instant response and you go through. So once you recover, you're confident that you found everything, go ahead and do those audits. What could you have done better? And then finally put in alerts. It's not about saying, well, now that I found that this door is locked and no one else can get in. No, it's about saying, hey, go install that Ring alarm system that when you lock the door, just in case someone brute forces it back in, that alarm's going off and you know. And you built that based off of all of your analysis and instant response phase, and your documentation now says, this is how you collect that evidence. If it goes off again, here's how you put together a timeline. Here's the tools to use. So what this is going to lead us to is, how do we even do this? I gave you all this primer, and it's like, wow, Terrence, you told us everything, but you didn't tell us the how. The how is as simple as you want it to be, but as hard as you make it. So there's going to be a few different logs that are great for you detecting lateral movement. So you're going to have your core audit log. So the audit log that you see when you're getting into Google Cloud logging, this is going to be the main log that you'll see. And there, the log name is telling you where did it come from, what resources were involved. You'll have your timestamp. Timestamp, Google's fun with their timestamps, so make sure that you're converting properly. It's not always going to be the the milliseconds that we're used to. So if you have scripts that are automatically doing that conversion, you'll notice that the timestamps may not work out. Then you have the proto payload. This is the bulk of the log. Proto payload also equates to being the JSON format that we're used to. So if you export it outside of Google Cloud, you will get it in the JSON format. But what proto payload is based off is protobuf. Difference between JSON and protobuf is protobuf has messaging defined, meaning that when I say resource ID, the message says resource ID is a string. Nothing else go in there. I cannot manipulate it. Makes it a lot more structured, and you'll see that Google Cloud logging builds on top of that for us. Going over, you have your authentication analysis. What is the source identity? Who was responsible for that? Then who is a principal email address? Do not confuse those two. Principal email address could be that service account, but the source identity was Terrence that issued the commands for the service account. Do not forget about your VPC flow logs. They're going to be great for you to understand what is going on when someone is moving across. Also understand what you have access to. When you're talking about flow logs, every service does not create a flow log. The reason is there's tiers. We talk about this in the 4509 class, where imagine this to be like a pyramid with infrastructure as a service at the bottom, platform as a service in the middle, and software as a service at the top. Infrastructure as a service means you have more access to logs, and that's going to be for your VPCs. So I will be able to understand because I'm at that level. But something that is software as a service, like a Google Cloud bucket, will not, because I don't have access to the networking of the Google Cloud bucket. The security log categories, Megan touched on these. Make sure you understand which ones are going to be pertinent for your investigation. When you're in these larger organizations, doing the equivalent of select star from all is quite dangerous. One, it sends your bill through the roof, but two, it makes it very slow. So if I just want to know the config changes, admin activity. If I want to know if something was denied, policy deny logs. And do not forget about the metadata fields, because this is going to give you those small bits of details that we're used to enriching if we're running our own SIM. All right, so this is leading us to our hands-on exercise. But before we get on our hands-on exercise, we're going to take a moment and talk about getting this spun up. So when you were in the aviata.cloud site, it walks you through creating the workshop. The workshop is hosted in AWS. So you must go through with your AWS account, follow the instructions for building out the Aviata cloud, and then you'll see that IP address is there. So what I'm going to do, I'm going to share just that. 1 second. All right. So this is what you'll see when you're starting up, but going over to our instructions, and you'll see on the instructions on our site for Aviata Cloud, it says you need your AWS account and web browser. Please start now. If you start now, it's going to take about 5 to 10 minutes for that VM to get running. So when you're inside of your account, you want to make sure it's done initializing. So what you're going to do, you'll go into your AWS console. You'll be in US East 2. You cannot do this from any other region. Make sure you're in US East 2. So it'll say US Ohio. And then you'll use the Cloud Shell, so that little icon here for the Cloud Shell. And from here, just copy and paste. There's no point of trying to be an expert on this part. You want to just click this little button here, copies it and pastes, and it walks you through how to get this script running. And once the script is running, it's essentially launching a Terraform in your environment that's going to boot up. And what you will see here is that it will give you the information about what was added here. So also do not forget, once we're done, these are all the instructions you're going to go through. But once you're done, make sure you do your cleanup. So resources are paid for as you use them. So when you're done with this workshop, this is here for you to go ahead and destroy to make sure you're not getting extra charges. So what you want to understand, coming over here, so you can see here that I ran mine, what you want to see to know that this is working is that under the status check, it should no longer say initializing. It should say 3 out of 3. If you attempt to connect to your IP address, the Kibana URL before that, you will not be able to connect to it because it hasn't started yet. So that's why I'm saying go ahead and get it done now. And then what I'm going to do while you're getting that up, I'm going to come back over here to the SOF-ELK. This is the screen that you will land on. Nothing much is here because our lab is very focused on non-network related logs. Inside of the course, or 4509, we'll be using VPC flow logs across Azure, AWS, and Google Cloud, and you'll see this same information populated. We're going to live in the Discover tab. So the Discover tab is where we're going to live, and our data is already loaded and segmented for us. We need to be in the GCP index to see the data. So right now I have it set on my time filter for the last 15 days, but the lab will give you instructions to where you will set this exact date of this. So I want to say it was December 2nd. And now, and you'll see on the histogram once you're there, it will have when the data in. You can drill further into that. But what we want to show here is for those who are not familiar with ELK, here are a few things to note. Building a visualization happens primarily through the visualize library. So if you want to build a table, build pie charts, it will not be like Splunk or other tools that you're used to. You must go build a visualization. But let's say you want to focus on some popular fields here. You could look here and you'll add the method name. So using these plus over here for the field names will allow you to build this kind of pseudo table. You're not really sorting on this table, but this is going to allow you to see it a little more clearly. Let's say you found something you want to interest in. There is this little toggle here where you have the ability to open up the individual log, and then you're going to see here. This is the data that's parsed. So we have a standard parser that was running here. Well, part of the lab, we want to notice what you know and what you did not know based off of how things are parsed. This is going to show you a little gotcha about what you usually see in your environments and why you want to invest in parsing. But this is just a breakdown of the table. You can see the different items here in the table. The JSON also allows you to see in a more raw form if you want to look that way. There are a few ways to filter in SOF-ELK. Let's say I'm going from here and I want to focus on, let's look at a good one. The resource location. I want to focus on logs that have US Central 1 in there. What that does is go up here and adds in a filter. So this filter that is had, think of this as a orders operation. The filters that are here are always run first. So when I go and run something like, let's say, service name, I'm going to say k8.io. When I run this, of course, did I not? Embarrassing. Of course. You know, when you do a live demo, it never actually works the way you think it's supposed to work. So let me go grab those absolute times here. Never do a demo live. I know, I know. Alrighty. Okay, that didn't work because a week ago was the third and the data is the first and second. So let's try this again. So let's say I add on, okay, now you just want to embarrass. Let's say I want to add on the resource location. We had the is US Central 1. So we add that filter, and then I want to do a service name. And we could do container.googleapis.com. Again, this is why you don't do demos live, because getting syntax correct is just not working. All right, we'll show a different. Come on, Terrence. I give up.
Wildcard without quotes. I don't think wildcards work in quotes.
Thank you. This is
Yep.
So what this wildcard is supposed to do is saying, give me any log with resource location US East 1, and it must have the service name in here. The wildcard is supposed to work like this. Yep. And you can then do wildcard, anything with container. You can also do the and operators and say severity info. And it will say the and over here. And we can also do a not in here as well. So that got rid of all those because there is nothing there. So that is just your quick primer for this environment. I'm going to go back over to the slides to get everyone aligned on what we're going to do. So we're going to be tracing some lateral movement with SOF-ELK. So here's our background. There, as a security analyst, you've been called to investigate suspicious API activity and container deployments that may indicate a breach of Mallegator Labs' Google Cloud infrastructure. The company's recent push to integrate AI capabilities in their aviation simulation platform has potentially exposed vulnerabilities in their cloud structure security posture. Your mission is to analyze the attack chain and determine how adversaries exploited these gaps. So there are a few instructions here, but the lab workbook that you saw, Megan has expertly put this together to make sure that if you have never done Google Cloud logging, you can go step by step, take all the hints. But if you have and you want to play around, see what you can find, you can just go answer the questions. So this lab takes about 30 minutes. So what we're going to do, we'll be back and check on you around like 11:25-ish, just to give you a overview of what you should have found, and then we'll wrap it up and you'll have access to go back through these labs and figure out what else you have there. Alrighty, I know the lab is titillating and you're probably still working your way through it, but we're coming to the conclusion of our workshop, so we want to give you a peek into what occurred in the lab. Then you'll be able to keep going. Megan and I will be on the Discord to be able to answer more questions for you. So let's talk about what actually occurred in this lab. All right, so let's do a review. So what actually was happening in this lab? This was a simulation of a supply chain attack. So we did this lab working backwards. So remember when we talk about our detection capabilities and what we're going to analyze, what we did detect was the failures of the API key creations. The failures actually occurred because that API was not enabled in the environment. So from there, we were able to see what IP address was associated with those failures. So you had that 34.172.104.252. So when you look at that IP address, you're able to see that there was also some activity where it was attempting to list out the objects and the storage buckets. So we see that activity already had some initial around the same time correlation there. Then if you dive further into what else did that IP do, you saw some activity around the Docker head blob. So for investigating the cloud, one of the things you must do is rely on the documentation here. So going to the API documentation would have been a more comprehensive way to understand what that method was and what does it do. But we went ahead and helped you to understand that is part of the artifact registry. This is where container images are stored. So if you're from other environments, it's going to be like a container registry, a Docker hub. And then what you saw there is that we were able to attribute that the Aviata Cloud Updater repository in US Central 1 was created by Chappie at MallegatorLabs.com. So here is where the parsing gets tricky. If we were doing this in the cloud native logging, so going inside of Google Cloud logging and looking at this, we would have saw a lot of more activity related to what was going on from the creation of this repository all the way through the end of the activity. But because of how nested the JSON was, the parser did not get it all. So this is why it's important to go test your parsing. So we left it this way just to show that you could be hampered a little bit when you're trying to do your investigations out of the cloud. So relying solely out of cloud makes it a little challenging, but it does not stop the show. What we did see with those logs is that the default computer service account was there that had multiple bindings of the editor role throughout their environment. And we was able to see that a container was being deployed. So what was missed by not being able to parse, you would have seen this if you go look at the raw logs or inside of Google Cloud Logging, is that the container was actually deployed to a Google Kubernetes engine. Inside of the Google's Kubernetes engine, once the container is deployed, you will see the GKA activity. And inside that container was a Python script. The Python script automatically grabbed the credentials related to that default service account and then attempted to get the API key, which is the failures that we saw. And then we saw the storage accounts key that were also being failures as well. When you look back onto why was there so many of this was just the simulation of the supply chain. Chappie was attempting to take a image that he got from Docker Hub and push it over to the artifact registry. Inside the artifact registry made multiple versions. And every time he tried to run it, Kubernetes ran it. And that's why there were so many failures there. So what the logs don't show in that next part of what we have to do for our analysis is being able to go back to the environment and pull the different things. How do we know what's important? Looking at these different terms here would have been all the different items of strings you wanted to pull on. So you saw the different methods there, seeing the different principal email addresses like the Chappie at Mallory Labs. There was also a default service account principal that said Aviata Cloud Dev. This one translated over to the compute service account. So you would have to pull the web a little bit to understand that the GKE had the default compute service count on there. And when it made the calls, that is what the service count looked at. Then you also had some few other calls in there. We saw the permission types of admin right, which is why things were being written there. We've seen different types of runtimes that were there. And that would have been some great information for you to dive deeper as you go through. So this wraps up the workshop for today. When we are looking here, we have a few different course runnings here, and we'll be able to take this course and do some similar labs here. I see that question there is that this environment is open at least through 2025. So going back, looking at this recording, reaching out to us on Discord, and also accessing the workshop here, we'll be able to still assist you and understand what's going on. So as long as you have your AWS account and the access to download the Terraform scripts, you can still run this lab. Upcoming courses we have, Megan is starting off the next course here with CDI coming up, and that is going to be this week, actually. CDI is right around the corner. So we have then a course by Corsten. This is going to be in our European regions. And then finally, we have my course in January, where it's going to be the San Francisco course and starting January 27th. For as we are at time, if there are any additional questions, you can drop them in real quick, or we can continue this conversation on Discord. But first and foremost, I want to say thank you for everyone who did participate. Big shout out to Hayes, who put this together. Laura, she had this brainchild of the Aviata Cloud mixed with all the other cloud instructors to put through a whole year's worth of courses for this workshop. So this was a brilliant exercise that Megan and I were able to participate in this year. Hopefully, so Hayes said we can go until 12, excuse me. So we can open this up until 12. But continue with the conversation, the Hayes, Laura, just putting this together, the other SANS instructors who did this was amazing. And then big shout out to Ben. Ben was making sure that this environment was available to us. And then always to my partner in crime, Megan. Megan and I put together this, and Megan is just brilliant. So always love working with her. So what we're going to do, we can open the floor up. Megan, do you want to show anything while we have our extra time? I thought we are ending,
Um,
but we have till 12.
yeah, no, I'm good. I don't think I have anything else to go over, but definitely for sure, let's leave it open. And if anyone wants to post in the Discord, or if there's anything someone was working through the content and they didn't fully understand, I think this is a good time. We can always hop into SOF-ELK and show you directly. So I think we wait for that. Just to plug, if you are in DC, definitely register and come join me later this week. If you're not in DC, my course is also hybrid, so you can join remotely. So it's not too late to register. I'd love to have you guys. But if not, Terrence, I can hook you up in January if you need some more time. But yeah, I think we'll keep an eye on the Q&A and the Slack, since we're running kind of short, and happy to demo anything in particular or cover any topics. I know Google Cloud is new compared to what a lot of the workshops has covered. So I think we're both happy to answer any of that.
And Megan, do you have the Kibana up so we can kind of show
I do.
people the kind of first steps on how you would investigate it? That way we can have it on the recording.
Yeah, let's do that. With our scenario, we started with the API keys. So, for people who are joining this, part of the challenge is that sometimes you don't know the log data well. Like ideally, if you're a Google Cloud environment, like you'll understand Google Cloud to some extent. You'll be familiar with those logs you learned beforehand. I really advocate for that. But sometimes that is not the case. So we talked here about creating API keys. One thing I like about SOF-ELK, you see these popular fields, available fields. Maybe I don't know what a field name is, but I kind of know like roughly maybe even part of what the field name would be or what it would look like. I like clicking on these fields and it'll give me a list of top values. So maybe I'm looking for actions and I'm like, oh, I don't see anything called actions really, but maybe this method name will be helpful. And like, okay, yeah, these are what I'm looking for. Now, again, I don't necessarily know the exact method name. You saw the method names. Some of them are like not necessarily intuitive. They're long names, so I might not have it. So that's where these wildcards come in helpful. So come in handy. So I'm gonna just search for API in the method name, and that immediately gets here. So when we were building this, Terrence was doing a lot of the simulation, and so I purposely came into the logs and started with. He told me that let's start with failed API keys created. So this is the search I ran. I didn't know that it was Google.api, like this huge string, but I searched for API in the method name and it comes up. All right. So looking at these events, I just chose one. They're all pretty close behind. And I wanted to see in here what information might be a good pivot point. So pivot points, again, that's the thing I hamper on a lot. You've got to find something unique. So this environment, it was a small lab environment, mostly just the attacker doing things. But in a regular environment, maybe API key creation is normal. So maybe you have to narrow it down more. We talked about how they were failed API keys created. So one of the things, if I look in here and look for the failures, if I'm not mistaken, if I look at the severity, it says error compared to ones that are successful. So now maybe I say, okay, well, I know it's failed attempts. I can just add this plus and build on my filters. So now I'm looking at failed attempts. So if there was a bunch of legitimate attempts, it gets rid of those. Now, unfortunately, part of our visibility gap here is we don't have a user tied to it. In this case, it was the service account. If you go into the raw logs, you'd be able to see that it does mention that service account. But again, we're only as strong as our tools in a lot of cases. The parser for SOF-ELK didn't parse this out. Maybe that's a lesson learned in future to go parse it out. But for now, I don't have that point. So what point can I use? And in the lab, we said, well, there's this source IP. That may not always be unique. There's cases with proxies and if you have a corporate VPN, shared IP space. But let's just see if there's anything here. So I click on filter. I'm going to remove my old searches and just leave that source IP filter. So now I'm gonna have all the actions by this IP, and you now see that it's before it was 15 hits, now it's 122. And immediately the first thing is I now see storage buckets being listed. So we see more activity from this. I can click again on here in the method name, and now I have the filtered down set of methods. So I see that from all these records, I've got some Docker activities, I've got the listing of storage buckets, and I've got API keys. If I wanted to, I can search and see if I've got any usernames available now. Here, it looks like some of our events do include it. So we see now there's a user, this 10352 address, -compute at developergservicecount.com. Now this account, the syntax of the, how it's written, this -compute at developer, that tells me that it's a default service count associated with compute engines. And as an analyst familiar with the field, or if I'm doing research on Google security attacks, I'll see those counts are popular for abuse. Let's see at this point if we can find this service account operating from another IP address. I don't know, but we might as well. There's less hits because of that thing, but it looks like no, when I remove that IP, it's still the same IP, right? So that IP, that username aren't the best pivot point. So like, let's look at some of these other events. So I see this serve blob. That's kind of grabbing artifacts from the registry. I can see that if I look at the permission that is used. So these permissions may allow for different methods to take place. The permission is not the same mapping to the method. So for all these different permissions here, all these different methods, whether it's get manifest or serve blob, the IAM permission that's allowing that is this artifact registry.repositories.download artifacts. Now, again, you may see this and you may have no idea what that is because it's your first time in Google Cloud or your first time interacting with this concept of an artifact registry. So I would just take this and do some Googling, find the Google Docs, maybe ChatGPT it, maybe AI does well enough, and try and understand what does this mean. What it does mean, though, knowing it or having done my research, is that Google has this service called Artifact Registry, and it's a container registry where you can store artifacts to be retrieved for builds. A repository is present in that artifactory, kind of like a repository you'd have in GitHub where it's got all the files and code related to a program. And then the permission is to download artifacts. So in this action, somebody, it's a data read event. This user is just downloading artifacts from this registry, this repository in the registry. All right, so knowing that it's interacting with this registry, maybe the registry is a pivot point. We know this registry is involved, this attacker's interacting with it. So let's get a filter for this registry, clear out the username, and now look at everything for that registry. We continue to see these data read events, the serving stuff, the getting stuff, those permissions. But now let's take that same field we saw before, and we see that now in some of these events, we also have an upload artifacts. So from the other IP, someone was downloading the artifact, so potentially taking the code to build some infrastructure. But now we've found the point in which that repository is being created, our data write events. And if we look through this data again, well, I just said that when we filtered, it was only those read events. We could have seen that when I looked at the IP address. So where do all these extra events come from, if not from that IP address? If I go here, it's in a similar subnet IP space. It's a 34 dot. But if we compare it to the last IP, this one is a new IP. Okay. We also see Docker in the command line. So we see that, there's some sort of Docker client being used. So pivoting again, we went from our API key method to our source IP on that method. We went from that source IP to a repository within our cloud dev project, and that's given us a second IP. So again, I'm going to replace my filter, and now I'm going to look at this IP. We see the Docker events again. And at any point, you could filter out the events you're aware of. Again, I could just go back to method name and look at the top values. And here, outside of the Docker events we've looked at, I now see these io.k8s events. That tells me that it's Kubernetes being interacted with. Probably the most, we see some lists and some gets. Obviously, it's important to know the threat actors reconning the environment. But what's a bit more interesting to me is write events. For example, a deployment being created. So I'm going to filter there and look at that deployment creation. And I see it's a handful of events. It's just the same activity occurring again. If you were to look at each event, you could build a table and see the values are the same outside the time. When I come here, I see there's a deployment created. I have that there's an app name in a namespace being a Kubernetes content. In the default namespace, I've created a deployment for an app called Aviata Updater. So we're getting more and more to the source of where did the attacker originate from. And we should be building these into a timeline, understanding where the creations are, deployment creations happening in comparison to the repository being uploaded and comparison to the API keys, etc. So we're kind of pivoting around a bit, but I'm getting more and more context out of this. So let me just look at this event quick. Look, we've got a new account. Choppy at Maligator Labs is the username. Before we were seeing that default service account in a few places, or the username wasn't present. Now we've got a new user. So we could dive into that user further. We have a user agent of kube control. That makes sense. We see that Kubernetes. Kube control is like the Kubernetes management application. But let's look more at this resource. Okay? So we went to the repository resource. That led us to an IP address, a new one, which led us to the Kubernetes activity, which led us to the Kubernetes deployment. And now I've got a whole bunch of hits. So a lot of these are just status updates, basic events. But we see the deployment being updated. That's this patch event. If we continue to look through, we see any other events that are happening, some deletions of deployments, so maybe some cleanup activity occurring. So we see a different stuff there. If we want to, we can also look at here we have a service account involved, the deployment controller. So that's kind of a system one. I'm actually going to go back now since I feel like I've seen a lot on that deployment. I'm going to go back and look at Choppy because I saw him on there. Let's see what he was doing. Ooh, username. I can spell. We have Choppy. There's a lot of hits now here. So this kind of tells me that that's probably like a legitimate user account and a regular user doing some information. You see kind of along with this deployment, there's some logging info. So maybe it was that user, maybe it's not. You would have to kind of get more into talking to that user, understanding what their behavior is. Maybe looking at login logs. You see, we've got 50 pages of logs. We can go back to really early on when the user is just looking at containers and trying to understand the environment. Again, maybe that's this regular for this user. So we want to look at where kind of that pivoting happens in the timeline, where it goes from Choppy to the service account on the deployment to the service account for the compute instances and so on. So that's like really high level. I kind of just wanted to hit on everything you see in the workshop. I hope that was valuable. Like I said, you guys do have access to that lab environment for the foreseeable future. We don't know exactly when it will go down, but you definitely, if you didn't get to walk through it right now, over the holidays, you'll definitely have more time, or right when you come back from the holidays, there'll be availability. Terrence, did you have anything else you wanted to share before we part ways?
No, nothing else for me. But again, a big thanks to Megan, my partner in crime, Hayes and Laura, who put this together and promoted this, Ben, who made sure this lab was possible, and all the other course authors and instructors that brought this possible to us through this workshop for a year. So thank you all for joining, and I appreciate it and love to connect.
Okay. Everyone have a great day. Enjoy the rest of your work day or your evening if you're joining from abroad, and we will see you at the next event.